From plane power to rocket fuel, it launched us into the space age. From the radio to the television, it opened our eyes to the world. From silent films to movies with sound, gave Hollywood's heroes a voice. They're all inventions of the Roaring 20s. A decade of hot jazz, freewheeling flappers, and bootleg booze. From the television to the lie detector to the liquid-fueled rocket, they're the inventions that shook the world. In modern theaters, it's all about sound. Imagine a monster without a roar, or an explosion without a bang. Scenes that once were silent, until an ambitious inventor took on Tinseltown. New York, 1920. Silent movies are all the rage, but the stars of the silver screen won't stay silent for long if Lee DeForest has his way. DeForest is already a famous inventor, but not famous enough. He wants to be a household name, just like Thomas Edison.
He was, shall we say, a unique and difficult individual to work with, to put it mildly. He worked best alone. He was a maverick. He certainly looked for ways of doing things that had been rejected by others.
DeForest's biggest success, the Audion tube in 1906, boosted telephone signals and created long-distance calling. But 14 years later, at age 47, he's desperate to come up with a big new idea to keep him in the limelight.
That man is so handsome. I can only imagine what he sounds like.
Maybe that's the ticket. Bring sound to the movies. DeForest figures if he could pull that off, he'd be a worldwide sensation.
With his background in audio engineering and amplification, that developing a working sound on film system was about the one last thing that he could do and he could make work as the lone inventor working in his back room.
But how to do it? The big challenge, as DeForest is about to discover, is that recording sound and recording film are two totally different technologies.
DeForest talking picture test number 1. This test is to determine the potential of a gramophone disc as a sound receptacle and playback device.
DeForest uses a horn which acts like a microphone to capture the sound waves produced by his voice. Those sound waves will then vibrate a needle and etch his words into the grooves of a soft wax disc. But when DeForest tries to match up the gramophone disc recording with the moving picture, there's a fundamental problem.
DeForest talking picture test number 1. This test is to determine the potential of a gramophone disc as a sound receptacle and playback device.
The mouth and the words keep going out of sync. It just doesn't work. DeForest comes back to the workshop with a glimmer of an idea. How about using light to record the sound right onto the film, just like a picture?
Which meant it always stayed in synchronization with the picture. They were physically the same bit of film, so they couldn't not stay in synchronization.
Testing.
DeForest connects his microphone to a light bulb device he calls a photon.
As the sound got louder, the light bulb would get brighter. As the sound got quieter, the light bulb would get dimmer.
After months of trial and error, they install the photon inside the camera and roll film.
This test is to determine the potential of sound exposed on film.
Inside the camera, the flickering photon exposes the sound of his voice onto the film. As it shifts from dim to bright, the photon creates a barcode down the edge of each frame. Each pulse of light creates a stripe that varies with the rhythm and intensity of his voice. De Forest has invented what's now known as optical sound. But does it work on playback? De Forest develops the film and puts it through a projector that converts the optical soundtrack back into sound. It plays in perfect sync, but now there's another problem. De Forest can barely make out the words. It's a huge disappointment. De Forest is on the verge of a breakthrough, but he can kiss fame goodbye if he can't get clearer sound.
He was also running out of money.
De Forest realizes what's causing the problem. His flickering photon bulb that exposed the sound onto the film isn't sensitive enough to accurately reproduce human speech. He's forced to admit he needs help.
Mr. De Forest? Theodore Case, at your service.
Theodore Case, a former Navy engineer, has worked independently on sensitive light signaling technology. De Forest knows he needs Case, but he's not keen on sharing the glory.
De Forest had very, very difficult working relationships with his closest collaborators. So instead of working with them in a way that mutually benefited them both, he wanted to go home with all the prizes.
An awkward situation. But Case needs De Forest's big name to boost his career, as much as De Forest needs Case's better light technology. Case adds a tiny, highly sensitive light bulb, which he calls an exciter lamp, to De Forest's sound system. It captures greater degrees of brightness than the photon bulb, so it's far more sensitive to the nuances of the voice. It could be the missing piece of the puzzle. Several months later, they're finally ready for a test. Whether or not their relationship is working, the important thing now is how the new light bulb performs. De Forest's legacy rides on what happens next.
De Forest talking picture. Hi. De Forest and Case, test number 3.
This time, the sound is perfectly clear. De Forest and Case have brought sound to the silver screen.
I think it will make us both very, very rich men.
Next, De Forest arranges a screening with one of his high-powered connections, Hugo Reisenfeld,
Case! Roll the projector!
musical director at the Rivoli, the New York theater known for its fabulous acoustics. The era of silent movies is about to end. These are the first movies with sound ever made. De Forest calls his system phonofilm, and Reisenfeld can't get enough of it.
Told you.
He snaps up the rights for the world premiere. On April 15th, 1923, De Forest unleashes phonofilm on the world at the Rivoli. Optical sound has arrived.
The underlying principle that Lee De Forest packaged up and made work was long-lived, and it's still with us in very many theatres around the world.
He never becomes as famous as the screen stars, but in 1959, De Forest receives the one thing every Hollywood star covets, an Oscar for his pioneering invention. More inventions of the 1920s. 1926, the chainsaw. The latest buzz in the bush can cut down 20 trees a day. Paul Bunyan, eat your heart out. 1925, cycle skates. Part skiing, part skating. Unfortunately, the new way to get around fails to go anywhere. And 1928, sliced bread hits the market. It's the greatest thing since, well, it is sliced bread. Coming up, the new machine that takes the hit and miss out of police investigations. and the guesswork out of confessions. How to get a criminal to confess. There's the nasty old school way. Then there's the civilized approach. Make him sweat, not bleed, with a polygraph test. A machine invented by a forward-thinking California cop. The year is 1920. At a California police department, a murder interrogation is about to get ugly. Observing the procedure is a well-educated young cop, John Larson. He's been hired to help modernize the Berkeley police. And he's convinced it's time to stop bouncing bad guys off the walls to make them sing.
Larson hated the idea of physical intimidation of suspects. It produced false confessions, it made citizens and suspects resentful.
John Larson is no ordinary cop. He's also a medical student with a PhD in physiology and a passion for how science can help solve crime. Larson figures there must be a more civilized way to extract a confession. As a physiologist, he recalls the suspect's physical responses: darting eyes, sweating brow, his shifting body language. It reminds Larson of a Harvard psychology experiment that tried to determine when someone was lying by measuring spikes in their blood pressure. The study's results were mixed, but the concept kicks Larson's medical mind into overdrive. What if he could create a machine that could monitor not just blood pressure, but several physiological responses? The criminal's own body might reveal whether he's telling the truth or not. Over the next 6 weeks, Larson hunts for the best instruments to monitor physiological responses. And with the help of a technician, he brings them all together into a single device. Larson will hook up his suspect with 3 separate instruments to measure blood pressure, heart rate, and breathing. All wired into a central device and connected to 3 needles that pass over a rolling drum of paper. As questions are answered, minute fluctuations in each physiological response will cause the needles to vibrate, recording them in a continuous line. Larson figures the stronger the vibrations, the bigger the chance the suspect is lying. The result is a machine that will become known as a lie detector. It's time to test it. Larson believes that for his invention to work, he has to come up with a standard procedure for asking questions.
Well, let's give this a try and see how it works. First question, what is your name?
David Johnson.
How long have you been married?
It's important to get people responses to completely innocuous questions like, did you have a cigarette this morning? So that you can compare that to the more intensely probing questions about the crime.
As Larson digs deeper,
have you ever been attracted to another woman other than your wife?
His test subject's physical reactions begin to change.
No.
It shows that he's uncomfortable and maybe lying. It's the response Larson needs. Over several weeks, he fine-tunes the way he asks questions. In test after test, his machine confirms a consistent pattern of physiological responses. Larson is ready to test his dancing needles with a real-life crime. He finds it here, a series of robberies at a Berkeley sorority house.
Cash was missing from drawers, jewelry had gone missing, and a diamond ring had been lost by Margaret Taylor, a freshman from San Diego.
Police are sure it's an inside job. It's up to Larson to find out which of the 90 sorority girls was the thief. Larson calls in 14 of them, a mixture of likely suspects and clearly innocent controls. Larson systematically works through the list, but the girls show no signs of physiological stress until he comes to Helen Graham. She's a student nurse from Kansas.
That machine's going to measure your heart rate and your pulse. I'm going to ask you a series of questions. I want you to answer them just as honestly as possible.
Well, I'll be telling the truth.
We're about ready to go. Is your name Helen Graham?
Yes.
Are you a student at Berkeley College?
Yes.
And as he worked through the questions, moving from those that were relatively innocuous and innocent questions to the one that pertained to the crime, he noticed that her blood pressure began to rise very dramatically.
Helen, do you know who took the ring?
No.
Did you take the money, Helen?
No.
The machine needles scream that he's found his thief.
I want to get out of here right now.
Before Larson can get a confession, Graham explodes in a rage and storms off. But the lie detector test has shaken her. Several days later, she fesses up.
I just saw it there, and I just took it, and I'm not a bad person.
The lie detector had notched up its first success. It had, for the first time, fingered the guilty party in a crime.
It's front-page news across the country. How Larson's test has exposed the thief.
But notice right away how it had done so. The lie detector had worked in the College Hall case because it made one of the people feel so guilty that they confessed to the crime. And that is how the lie detector has worked ever since.
The lie detector isn't foolproof, so its results are only rarely accepted in court. But its psychological effect is huge and helps investigators bring new information to light. Larson's invention had one other long-lasting effect. Believe it or not, 1 year later, John Larson married Margaret Taylor, the innocent victim of the crime. And that's the honest truth. More inventions of the 1920s. 1929, the folding electric car. It's the original compact, perfect for the lady who wants to keep her car in a cupboard. It hasn't been seen since. And 1929, the electric shaver takes the risk out of razors and massages its way across the chins of America.
Will give you a close, comfortable shave, no matter how tender your skin.
Coming up, Albert Einstein takes a turn in the kitchen and comes up with a brilliant new appliance to save lives. Today, the biggest challenge when buying a fridge is in the details. 2 doors or 1, white or stainless. A lot easier than in the 1920s, when buying a fridge could literally cost you your life. A deadly problem that inspired the humanitarian side of the century's greatest scientist. Berlin, 1925. Albert Einstein, the Albert Einstein, solver of secrets of the universe, is about to turn hands-on inventor over his morning glass of milk.
Einstein was a very quiet person. He spoke with a slightly squeaky voice, and he was self-effacing and a bit modest.
The rest of the world sees Einstein as the rock star of scientists. He's already won the Nobel Prize in Physics, and then he turns the science world on its head with his theory of general relativity. But this morning, he's not thinking about relativity or quantum physics or even breakfast. He's captivated by a horrifying story in the morning paper about a fridge. A fridge that's killed an entire family overnight.
The refrigerator leaked ammonia into the apartment, which is toxic and which eventually filled the rooms and killed the family.
The household refrigerator is a recent invention that's got a deadly problem. It uses toxic gases, like ammonia, as coolants to absorb heat from the food chamber. Einstein's thoughts come swooping down to earth, from theories of the universe to building a safer fridge, and he knows just the guy to help him. He calls in his friend Leo Szilard, a Hungarian student physicist.
Both of them were humanitarians, both of them were pacifists, and both of them responded on a personal level when they read that a family had been destroyed by a faulty refrigerator.
Szilard himself will later create nothing less than nuclear fission. But right now, Leo and Albert are fixated on a fridge. They observe that the fridge has several mechanical moving parts required to circulate the liquid coolant. One of these parts is a compressor pump. It rattles constantly, and that creates wear and tear on the surrounding valves and seals. They realize that it's the mechanical moving parts that allow the toxic coolant to leak and turn the fridge into a ticking time bomb. But how can they move the liquid coolant through the fridge without mechanical parts? As physicists, they're both familiar with a powerful invisible force called electromagnetic energy. Einstein thinks they can harness that energy and use it to push the coolant through the fridge's coils. They'll need an additional component, a liquid metal that is a strong conductor of electricity. Szilard suggests a sodium-potassium alloy. The idea is to send an electrical current through the liquid metal. The resulting magnetic field will turn the liquid metal into a kind of piston that pushes the coolant through the refrigerator's coils. Early in the experimenting, they run into a snag. The sodium-potassium alloy is too acidic, and it corrodes the wires that they've inserted into the tube to create a current.
So they needed another method.
That's when another light bulb goes on in Einstein's big brain. Why not scrap the electrical wires inside the tube and replace them with electromagnets in the form of coils around the outside?
Imagine yourself taking a string of sausage and squeezing the sausage as it goes around. The magnets were in effect doing the same thing.
By sending electricity through the electromagnets, he will create magnetic fields that penetrate the tube. The magnetic forces will push the liquid metal through the tube, forcing the fridge coolant to keep moving as well. What Einstein has come up with is the world's first electromagnetic pump, a pump with no moving parts. Within a few months, they have a prototype ready to test. When they turn it on, it works. The milk's cold, and they've made the kitchen a safer place. But it does have a significant downside.
It started making louder and louder sounds. Somebody who was there said it howled like a banshee.
That doesn't faze the two theoretical physicists, but to lesser mortals, the howling fridge is a tough sell. What makes it even harder to sell? In 1929, scientists discover Freon, a non-toxic coolant that eliminates the reason for the Einstein fridge. But the domestic invention conceived by the world's great brains ends up with an even more important role in nuclear power plants, cooling the reactors. It's the kind of ending you might expect when two of the 20th century's greatest minds sit down to build a better fridge. More inventions of the 1920s. 1925. Gyro wheels make the world go round, guaranteed to shape you up if gravity doesn't shut you down. And 1927. Kool-Aid, an American chemistry geek, cooks up a concoction in his mother's kitchen and markets his drink powder to thirsty kids.
A 5-cent package does the trick, makes 2 quarts of Kool-Aid quick.
Coming up, A Scottish inventor uses a hat box to send moving pictures into your living room. From high-definition jumbotrons to old-style sets in remote rural villages, television has made our world a whole lot smaller. It's the medium that links us by the billions during events of triumph and moments of tragedy. All thanks to a Scotsman who was down on his luck and determined to make a comeback. It's 1923 in the seaside town of Hastings, England. Inventor John Logie Baird is hoping the fresh sea air will improve his chronic bad health. It better. Baird is a genius, but his health problems and his life of inventing have left him seriously broke.
My father came across as being rather withdrawn and not quite with it. You would say something to him and he wouldn't necessarily respond to it because he would be thinking of something else. But he was always polite.
Baird has been inventing ingenious gizmos and gadgets all his life. His chemically saturated damp-proof socks for the troops in the trenches were surprisingly successful. But his inflatable pneumatic shoes never made him a penny. By the time he hits Hastings, he's out of money. But Baird has an idea that just might let him invent his way out of his predicament.
Here he was with £100 left, and he had to think of something. And that was television.
What Baird is imagining is a huge technological leap. Transmitting sound over great distances by radio is still new. So transmitting moving pictures seems like science fiction. So how do you capture a moving image and transmit it through thin air? He sketches a device he hopes will work. He starts with a disc fitted with a spiral of perfectly spaced holes. Powered by an electric motor, the disc will spin in front of an image. As it spins, each hole in the spiral allows a tiny slice of the image to pass through. A light sensor picks up these little image slices and converts them into a series of electrical pulses. The pulses are transmitted by radio waves to a receiver that reads the signal of the pulses and reconstructs the original image on a second spinning disc. Baird gets to work using a bunch of scavenged parts: knitting needles, a bike light lens, a biscuit tin, and a hat box.
He started from scratch, really, with television. He bought a few components, he sort of put them together in his bedroom.
The hat box lid turns into his circular scanning disc with a spiral pattern of holes. He'll spin it on a knitting needle shaft. Piece by piece, he assembles it, using coffin wood from a local undertaker as a base. It's finally ready to be tested. Baird has staked everything on his tiny spinning pinpoints of light. Baird sets up a simple cross in front of the scanning disc. He syncs up the receiving disc at the opposite side of the room and watches to see what his crazy contraption can do. As if by magic, it appears. As the receiving disc spins, it reassembles the shadowy shape of the cross. Baird is ecstatic. It proves his basic assumptions are correct. But a clear image is still a long way off.
It took him a little longer than he thought it would. It took him several years.
By 1924, Baird is now living in London, which gives him better access to equipment, but the smoggy air is disastrous for his health. In a Soho flat, still penniless, he works day and night. Slowly but surely, the blurry shapes get a little clearer, a bigger scanning disc, a more sensitive selenium light sensor to create better detail in the electrical pulses, and above all, a lot more light. But he still can't find the right combination to produce photographic gradients of gray. It's key. Without those tones, he can't create a recognizable human face.
He was beginning to lose heart. This was in late 1925. And his backer, he had a backer at that point, was becoming very impatient and wanted out.
It's October 1925. The day starts out like so many before it. For the umpteenth time, Baird places the head of a ventriloquist's dummy in front of the scanning disc. He floods the room with light as the scanning disc begins to spin. But this time, things will be different. Over in a separate screening room, there appears on the synchronized receiving disc, out of nowhere, the world's first ever detailed television image. He's finally got the magic combination. Baird knows at once it's a major breakthrough.
He could hardly believe his eyes, and it came as quite a shock when it eventually came.
Baird can't wait to do a test with a real human subject, the office boy from downstairs. 20-year-old William Tainton is terrified. He sits confused as Baird rushes back to the screening room. As the discs sync up, Baird instructs him to move his mouth.
William, stick out your tongue!
William Tainton, the first human face ever to be seen on TV. John Logie Baird and his miraculous new invention have arrived. This first recorded image from Baird's TV only has 30 lines of resolution, compared to over 500 on standard TVs today. But the features are recognizable in shades of gray. Baird takes his television public. The first tiny screens are a sensation. Within 4 years, the BBC transmits its first official TV broadcast using Baird's mechanical system.
But in a very quiet way, I'm extremely proud of what my father did.
Thanks to the relentless determination of John Logie Baird, the world now has television. The global village is born. More inventions of the 1920s. 1924, frozen food, patented by an American naturalist who'd learned all about flash freezing from the Inuit. It's a huge hit with consumers.
By 1957, no less than half America's food money will be spent on frozen pets.
1922, the first 3D feature film premieres in Los Angeles, complete with stereoscopic glasses. And 1920, the 3-color traffic light. While Henry Ford's putting a car in every driveway, a Detroit policeman comes up with a way to keep everybody moving. We've been running reds ever since. Coming up, an explosive obsession finally gets space science off the ground. Since the late 50s, we've launched almost 7,000 spacecraft beyond Earth's atmosphere, an average of 1 every 3 days. Today, we take spaceflight for granted. But for the father of modern rocketry, it was a tough struggle to find believers. 1915, Robert Goddard heads for his lab at Clark University in Worcester, Massachusetts. He's a brilliant professor of physics. He's also eccentric, with an outrageous idea. If the world knew where he intended to send those rockets, they'd call him crazy. It all started when he climbed a cherry tree at 17.
The story is that Robert Goddard climbed into that cherry tree and he started daydreaming. Now that's something that Goddard did a lot of. Don't know how long he was up in that tree, but he had an idea that we could get to space, and he wanted to be the person that did that.
Getting into space seemed like a crazy idea in an era when airplanes were just getting off the ground. But Goddard always had his own ideas about how to make things move, even if his experiments looked kooky to other people. And he had a lifelong obsession with things that go boom.
Early on as a student at the university, he set off a small rocket in the basement of one of the buildings, and boy, did it make a huge explosion and a lot of smoke. He was lucky he did not get expelled.
By his early 30s, Goddard is still obsessed with making spaceflight possible. But now he thinks he knows how. We see fireworks as toys, but Goddard sees a way of getting into space.
Fireworks are solid fuel rockets. You take a bunch of powder, you pack it into an enclosed space, you put sort of a wick in there, you light it, and off it goes with a big boom.
Goddard thinks that this simple concept, igniting solid fuel, could propel a rocket into space. But first, he needs to figure out how to make the powder burn in a more controlled way, so it doesn't explode all at once. He envisions a special combustion chamber at the base of the rocket. He fills the chamber with a solid fuel explosive, like gunpowder. On ignition, powder is fed into the combustion chamber bit by bit. So instead of going off in one big blast, the rocket is carried aloft by a series of staggered explosions. It's a whole new way of thinking about flight, and Goddard thinks about it day and night.
It's said that Robert Goddard was so busy at night that he couldn't tell you the next day what he had had for supper.
In a remote corner of the campus, Goddard starts work on small-scale models. He records the power of their upward thrust and calculates what would be needed for a full-size rocket. But progress is slow and tedious. All the while, Goddard tries to keep his work secret.
They were constantly trying to get Robert Goddard to write up his findings. And he didn't want to do it because he was afraid, one, they get stolen, and two, people think he was a nut.
Goddard discovers that only 2% of the energy produced by the burning fuel actually contributes to thrusting the rocket upward. That's not enough power to get him anywhere near space. He searches for something to increase the engine's thrust, its ability to propel the rocket into the sky. His research leads him to a steam engine part called a de Laval nozzle. Goddard thinks he's found his solution. The hourglass shape of the de Laval nozzle forces the hot gases from the combustion chamber to move 8 times faster as they squeeze through the narrow part of the tube. Goddard thinks that as it expands again, the exhaust flow will be converted into powerful kinetic energy, blasting the rocket to speeds unheard of at the time.
The de Laval nozzle really moved Robert Goddard's ability to achieve what he wanted to achieve forward at a faster pace.
By the summer of 1915, Goddard is experimenting with the de Laval nozzle. He calculates the thrust and discovers that the new nozzle boosts the fuel's efficiency from 2% to an astonishing 63%. Still not enough to put a life-size rocket into space, but it proves that Goddard is on the right track. The theoretical dream of spaceflight is turning into a real possibility. But his problems are far from over. Goddard is running out of money. Until now, he's been paying for his obsession out of his $1,000 teaching salary.
He learned pretty quickly that he couldn't live and do rocketry at the same time. Couldn't pay his bills, couldn't eat. And so that's when he sent his first letter to the Smithsonian Institute and started to ask for money.
In order to get funding, he has to publish his work. So he writes a paper about the experiments with solid fuel and the theoretical possibilities for exploring space. The good news, it gets him a $5,000 grant from the Smithsonian. The bad news, he is ridiculed in the press. The New York Times declares the idea of rocket travel preposterous.
He could have said, yeah, well, maybe they're right, and spent the rest of his career teaching. Perseverance was in his nature. Overcoming was in his nature.
Goddard continues his work, but now he's facing a new problem, and a big one. As he gets deeper into his experimenting, it becomes obvious that solid fuel is not going to work. It's just too hard to control, test after test ends in failure. Goddard has been at it for 2 decades. With a failure of solid fuel, it looks like all his work has been for nothing. After 2 decades, Robert Goddard's research into solid fuel as a way to get into space has hit a dead end. So he goes back to an idea he had 10 years before. How about replacing solid fuel with liquid fuel?
This gives you an insight into Goddard's perseverance.
He begins experimenting with gasoline. And to make the gas burn with more power, he adds another liquid, liquid oxygen. He hadn't tried liquid fuel before because the liquid oxygen had always been too costly to buy and too difficult to handle. It has to be kept extremely cold. Now, at last, he has the resources to try it. The potent gas and liquid oxygen mixture isn't just more controllable than solid fuel. He discovers it also has more energy per unit. The fast-moving, high-pressure stream of hot gases should add huge power to the thrust of the rocket. It's the last key ingredient. Goddard thinks he finally has his fuel.
To be successful, he had to develop, to invent, to create the liquid fuel engine.
Goddard imagines the liquid fuel engine with 2 lines running into its combustion chamber, one feeding fuel, the other oxygen. The liquid oxygen is extremely cold, but the combustion it produces is extremely hot. To prevent overheating, the cold liquid oxygen cools the combustion chamber on its way from the fuel tank. Goddard gets ready to take his launching gear out of the lab and into the field to test the new fuel.
March 16th, 1926, this is going to be the test.
A liquid fuel rocket is a totally new technology. Anything might happen.
The December prior, he'd gotten one foot off the launch pad before it fizzled out and didn't go anywhere.
It's one man pursuing his dream against all the conventional wisdom of the day. But conventional wisdom isn't going to get anyone into space. There's nothing left to do but take a deep breath. For 20 of the longest seconds of Goddard's life, nothing happens. And then it takes off. The rocket shoots 41 feet into the air and lands 144 feet away. There's still a long way to get to space, but Goddard has proven that his concept will fly.
It flew, didn't go exactly where he wanted it to go, but it flew, and it proved that a liquid fuel engine could succeed.
In 1926, it's the most powerful rocket ever launched. Over the next 20 years, Goddard launches more than 50 liquid fuel rockets, each one bigger than the last. Scientists in Europe and America are soon building rockets based largely on Goddard's innovative work. But Goddard's real dream doesn't come true until 1969, 24 years after his death. The Saturn V rocket, powered by a liquid fuel engine, blasts the Apollo 11 astronauts to the moon.
Everything that was achieved was built on the technology that he spent 2 or 3 decades struggling to make work.
The New York Times publishes a retraction of its mocking editorial of 49 years before. Goddard had been right after all. Robert Goddard is now recognized as the father of space exploration. If you are ever on the moon, you'll find a crater named in his honor. And so ends the roaring 1920s, in what is the most inventive century the world has ever known.